So as we saw in the previous video, hypothesis testing has a very firm logic behind it that we have to abide by when creating our null and alternative hypotheses. There's a structure to these hypotheses that we cannot avoid based on the fact that this all has to follow a mathematical pattern. So in this video, we're going to learn how hypotheses are structured and how we work with them. So the null hypothesis is H with a little zero after it. That's a zero. Also called H naught, as in all for naught, N-A-U-G-H-T, or H null, or H zero, right? It's a statement of no change or no effect, no difference in the population parameter of interest. The statement is assumed to be true unless we can gather enough evidence to prove otherwise. Well, not to prove otherwise, but to indicate otherwise. The alternative hypothesis, sometimes it'll be H1 or sometimes it'll be HA for alternative, right? So 1 because 0 and 1, right, are opposites of each other in binary code, or A for alternative. That's a statement that claims that there's some change, that it has gotten more, it has gotten less, or it is different than the original population parameter that we assume to be true. So when we run a hypothesis test, it's a little bit like a trial, as in we assume the null hypothesis is true. It's sort of like assuming innocence until proving guilt, right? So we assume the null hypothesis is true. And if the data provides strong enough evidence against that null hypothesis, we will reject it and believe that the alternative is true, the alternative hypothesis. It might not be, but that's the belief we will hold based on evidence. All right, now there's 4 potential parameters that we can work with. There's the population average, right, or mean, right? That's mu. That's a Greek letter. It stands for population mean. And of course, we learned that often the word mean is changed with the word average, interchangeable. It's not technically correct. There's lots of averages, but that's the word that gets used a lot. And then there's the population proportion. We've been seeing that since chapter 8 or so, right? Proportion or percent. Those two are the two we're really going to work with. But I did want to mention that we do know a couple other values that could be population parameters for us. That one we saw in chapter 3. That's the population standard deviation. I'm not going to write it all out. Or the population variance. And those two we'll just talk about in this section, but we probably won't do any actual hypothesis tests with them. They can be done, but we won't do them in our course. Okay, so let's look at some of the types of tests we can run. Now there are one-tailed tests because they only go one direction. So one-tailed tests would be the left-tailed and the right-tailed, because left and right are one direction only. So those are one-tailed tests. Now we can have a left-tailed test or a right-tailed test. And then there's also the two-tailed test, which is not a one-tailed test because it's two-tailed. All right, so for right-tailed, let me give you an example. It would be something like H naught, H0, would be P equals, I'm just going to give you an example of 1/4. And the alternative to that is that P is greater than 1/4. So these are symbols. So I'm writing this out, this hypothesis, in symbols. If I wanted to write words for each of those, I could. It would be that the proportion, I'm just going to write this down over here. This would be that the proportion is, I'll just say 1/4. And this one would be that the proportion is more than 1/4. So those would be words for those same symbols. The symbols are what we use most of the time, but it's not a bad idea to realize that you can translate back and forth. This is standing for proportion, that symbol means more than, and that means 1/4. And actually, let's talk about the more than, because we want to kind of get some ideas for which way a greater than sign, which is what this is. That's a right-tailed test. What are some words? So because those will be the words you want to look for in your problem. So more, greater, increase, right? Things that going up. Oh, go up, go up, above. And I'm not going to come up with every word, right? So there's a lot of them. Exceeds. Exceeds means it's getting bigger. And actually one of the trickiest ones is at least. Because in English you see the LE and you think it means less than, but it doesn't. At least actually means greater than. So all of these are words for greater than, right? Or for more than. They're synonyms for that. This would be a handy list to have on hand, say for like your note sheet for your exams. All right, now what about a left-tailed test? Okay, so let me give you an example. So the symbols, I'm going to write over here. I could have H naught would be, and I'm just going to make up a different one. So I did a parameter proportion right there. I'm going to do a mu. So the mu is 98.6, right? Everybody thinks body temperature's average is 98.6. So if I was going to write words, I would say the average is 98.6 degrees Fahrenheit. I didn't really put context in there, but it's obviously body temperature, right? And then the alternative, H1, I'm going to do a less than. Mu is less than 98.6 degrees Fahrenheit, which would tie together with the average. I'm gonna put the context in here. Body temp is less than 98.6 degrees Fahrenheit. I realized it wasn't fair to include context in only one of them, so I made it the context in both of them, right? Because if you're going to include context, you want to include it in both pieces. Okay, so now we're seeing the word less than. Less than is key. So what are some other words for less? Okay, so less or less than, smaller, lesser, increase goes with decrease, right? So these will be words that make it a less than symbol, left-tailed test. Below, go down, reduces. And the companion to at least is actually at most. That's a tricky one. So at least is a right-tailed, and at most is a left-tailed. All right, now what about a two-tailed test? So this was a left-tailed, this was a right-tailed. Those are both one-directional tails. But what about a two-tailed? Well, then it could go either left or right. So for example, what if let me write this in symbols here. What if sigma equals 2 versus the alternative, sigma is not equal to 2? So in words, I don't have a context for this one, so it'd be that the standard deviation is 2. I could give it units. Let me give it mg, just for fun. 2 mg. That would be the words. And over here, it'd be that the standard deviation is not, that's what the slash through the equal sign, is not 2 milligrams. Right? So those are the words that tie to those symbols. And again, usually the symbols are what we actually use in practice, but we also use the words for certain applications. So it's helpful to keep them both in mind, right? The words and the symbols. Now, what about that word? Well, you saw this is a little strange. The not equal to kind of doesn't have a lot of words in English that work for it. So it's a two-tailed test. It's not equal to right here. And so not is one of the big ones, right? Not or not equal. The two most common words we see besides not are different and change. The value has changed, right? Or change or changed. Okay? So if you see that, that's implying that it is not what it used to be. It is not equal to.